Hello students, today we will discuss about the Bohr's atomic model. Okay, in this session we will study about the postulates of Bohr atomic model, okay, as well as the mathematical calculations of the velocity, energy, frequency and other things of the electron according to the model. Okay, now let's start. So Niels Bohr, he gave an atomic model and also gave some postulates of his model. Since this postulate contains 3 to 4 points, there are mainly 3 or 4 postulates, we have converted all these postulates into easier points. Okay, 7 to 8 points, and we will study them. Now first postulate means first point is that he told that every atom contains nucleus at its center, okay, and in the nucleus neutrons as well as protons are present, and electrons revolve around the nucleus in the closed circular paths. These closed circular paths are also called orbits as well as shells. Afterwards, he told that since electron is revolving around the nucleus in fixed energy, means in circular paths or orbits, and these orbits are also called stationary states, or we can say stationary orbits. Okay, so he told that electrons are revolving in orbits or stationary orbits, and he also told that every stationary orbit is having a fixed amount of energy. Okay, for example, if this is n is equals to 1, then it is having a particular amount of energy. If second stationary orbit is there like n is equals to 2, then it is also having a fixed amount of energy. So he told that every stationary orbit is having a fixed amount of energy. Now he told that around the nucleus, not only fixed stationary orbits are there, but infinite number of stationary orbits are present. Okay, and all these infinite number of stationary orbits are having different amount of energies. Every stationary orbit is having a fixed amount of energy, and so on, he told. After that, he told one more thing, that electrons revolve only in that stationary orbit in which the angular momentum of electron is the integral multiple, that is the integral multiple of h upon 2 pi. He told that electron will revolve only in those stationary orbit in which the angular momentum, which is represented by L, the angular momentum of electron is the integral multiple of h upon 2 pi. Integral multiple, that means the value of n must be an integer. Okay, like n is equals to 1, 2, 3, 4, etc. Here h is the Planck constant, 2 pi is a constant quantity, L is angular momentum. Since angular momentum, that you will study that it is the product of momentum as well as the distance or r distance. So, and linear momentum P is also known as mv, so it will also be equal to mvr is equals to mh upon 2 pi. Okay, since already I have explained you about it, so mvr is equals to mh upon 2 pi, so electron will revolve only in those stationary orbits in which the electron, their angular momentum will be integral multiple of h upon 2 pi. Okay. So we can say also that electron will be present in the orbits having angular momentum h upon 2 pi, means 1h upon 2 pi, 2h upon 2 pi, 3h upon 2 pi, means in such type of orbits electrons are present or electrons revolve. After that, he told that energy of each orbit, that is energy of each stationary orbit, is fixed. But if the distance from the nucleus increases, then continuously the energy will also increase. That means the energy of electron is directly proportional to the distance from the nucleus. Like this is the closest shell from to the nucleus, n is equals to 1, n is equals to 2, it is at a distance, means less closer, Like in the same way, if the distance increases, then continuously the energy of orbit and electron in the orbit, it continuously increases. And at infinite, when it is at infinite, the energy will be zero. Why energy will be zero? Energy of electron will only be zero when it gets free from the atom. Okay, so this is the order of energy. He told that the energy of electron in these shells, it is negative, means lesser amount of energy is there, but it is continuously increasing. Like in K shell, it is about 13.6 electron volt for the hydrogen atom, minus 13.6 electron volt. Okay, he told like this. Now he told, the next point he explained was that in any orbit, the electron is revolving. Like in n is equals to 1, the electron is revolving. So during revolution, the electron will neither gain or nor lose any energy. Means during revolution in its own stationary orbit, electron will never gain or lose energy. Okay, electron means the stationary, means the lowest energy state, that means the energy will not gain or lose energy. And he also told that the lowest energy state of any, means lowest orbit in which electron is present. Okay, lowest energy orbit, lowest energy stationary orbit is there in which electron is present. That position of electron is also called ground state. It is the lowest energy state, and n is equals to 1, suppose it represents the ground state of electron. And when the electron will move from n is equals to 1, means electron will move from here to other orbit, then those states are the excited states of electron. Like n is equals to 2, it is called the first excited state. If the electron is moving from n is equals to 1 to 2, then it is first excited state. Electron is moving from n is equals to 2 to n is equals to 3, this will be the second excited state, and so on. So these are the 5 points. Now the next postulate of the Bohr's atomic model is, since in the fifth postulate we have discussed that when electron is present in its own stationary state, then it will neither gain or lose energy, and it will continue revolve in the same orbit. But next thing is that in next postulate it is told that if any electron get energy, means if any electron get energy, means absorbs energy, then it get excited from one stationary state or one orbit to the other stationary state or other orbit. ओके, तो इलेक्ट्रॉन है अगर ये एनर्जी एब्जॉर्ब करता है, सिंस इट वाज आल्सो टोल्ड दैट इलेक्ट्रॉन ऑलवेज एब्जॉर्ब एनर्जी इन द फॉर्म ऑफ photons. Photons are the energy packets. Okay, so and energy of one photon is equals to h into nu. Nu is the frequency. Okay, so if electron is absorbing energy, then it get excited from one energy state or one stationary state to the other stationary state. सपोज मान लेते हैं कि इलेक्ट्रॉन है, उसको यहाँ पे पहुँचने के लिए x एनर्जी चाहिए और उसके पास में क्या है, मान लेते हैं, लेट्स अ इजी एग्जांपल, यहाँ पे पहुँचने के लिए सपोज इलेक्ट्रॉन को कितनी मतलब बहुत ही कम एनर्जी चाहिए, मान लेते हैं x ही मान लेते हैं, x इलेक्ट्रॉन वोल्ट एनर्जी चाहिए और यहाँ पे इसके पास में कितनी y इलेक्ट्रॉन वोल्ट, तो ये क्या करेगा, एनर्जी को एब्जॉर्ब करेगा. जब तक इसकी एनर्जी एब्जॉर्ब होकर x के बराबर नहीं आएगी तब तक ये एक्साइट नहीं करेगा, लेकिन जैसे इसको एनवायरनमेंट से बाहर से या कहीं से भी इतनी एनर्जी मिली जो कि x के इक्विवेलेंट हो जाती, देन इट गेट एक्साइटेड. ओके, सो इन दिस वे इट गेट एक्साइटेड फ्रॉम वन स्टेशनरी स्टेट टू द अदर स्टेशनरी स्टेट एंड सो ऑन. ज़्यादा एनर्जी मिल गई तो ये बहुत ज़्यादा ऊंचाई पे या गैप मार के भी क्या है, ये मतलब जा सकता है, जंप कर सकता है. सो ऑलवेज व्हेन इट गेट एक्साइटेड फ्रॉम लोअर स्टेशनरी स्टेट टू हायर एनर्जी स्टेट, देन इट ऑलवेज एब्जॉर्ब एनर्जी. ओके, एंड व्हेनेवर इलेक्ट्रॉन is coming from higher stationary state or higher energy state towards the lower energy state, then in that case energy always emit the energy. Electron always emit the energy in the form of photon only. Okay, because if it is at higher energy state, that means it is having a large amount of energy. So whenever it is losing energy, it is having lesser energy, so it comes to the lower excited state. One more thing is there, that whenever electron gains or absorbs energy, then it gets excited to the other states, or it get excited to the other energy levels, but it is highly unstable over there. Okay, it will remain in the excited state for a very few fraction of time. Okay, second. So this is okay beta. Now whenever electron move from one energy state like lower to higher energy state, then the difference in energy means the amount of energy that get absorbed or that get emitted, that will be equal to the energy of the higher energy state. Okay, energy of higher stationary state minus energy of lower stationary state, that is En2 minus En1. Here N2 represents any of the orbit, any of the stationary state from where electron is coming, and En1 is the means that orbit means energy of means orbit of the lower energy. Okay, and that will be equal to h nu. Okay, fine. So this is the sixth postulate. Now next postulate given by Bohr was that whenever electron revolve in the circular revolve in the circular orbit or stationary orbit, then it will continue revolve until the centrifugal force acting in outward direction over the electron will be equal to the force of electrostatic attraction between electron and protons or positive charge of nucleus. तो इसको उन्होंने बताया कि किसी भी ऑर्बिट में इलेक्ट्रॉन तब तक रिवॉल्व करता रहेगा जब तक इलेक्ट्रॉन पे बाहर की तरफ लगने वाला सेंट्रीफ्यूगल फोर्स और अंदर की तरफ लगने वाला जो इसका न्यूक्लियस है, इसका जो अट्रैक्शन है, वो दोनों सेम होंगे. सिंस इलेक्ट्रॉन हियर द कंपोनेंट ऑफ वेलोसिटी मीन्स द वेलोसिटी is in this direction, that is to the tangent at the point of electron, at any means to the tangent of the path of any point over the path of motion. So centrifugal force will be equal to the electrostatic force. तो यहाँ पे centrifugal force कितना होता है, mv square upon r, and electrostatic force kZe square upon r square. ये कैसे होता है, देखो कोई भी दो चार्ज पार्टिकल, like here it is E one electron and here it is Ze. ये Ze कैसे आया बेटा, मैंने आपको बताया वैसे भी. तो Z यहाँ पे क्या एटॉमिक नंबर एंड E इज द चार्ज ऑन प्रोटॉन. इन हाइड्रोजन Z इज इक्वल्स टू 1 E इज यानी 1 प्रोटॉन होता है, या 1 E लिख सकते हो आप, प्लस 1 E. अगर अपन सोडियम की बात करें तो 10 E हो जाएगा. सो इट वेरी ना, दैट्स व्हाई इट इज Z. ठीक है, तो चार्ज ऑन न्यूक्लियस इट वेरीज एंड इट विल बी मल्टीपल ऑफ the one charge on one proton to the atomic number. So Ze, इन दोनों के बीच डिस्टेंस कितनी r, सपोज दिस इज डिस्टेंस r. तो इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन कितना होता है, डायरेक्टली प्रोपोर्शनल टू प्रोडक्ट ऑफ चार्जेस, दैट इज E इंटू Ze अपॉन स्क्वायर ऑफ डिस्टेंस बिटवीन दैम. प्रोपोर्शनलिटी का साइन हटता है तो आता है K कप्पा कांस्टेंट. सो इट इज द वैल्यू ओवर हियर लाइक दिस. Okay, so if both the forces will be equal, only then electron will continue to revolve in the same orbit. Next, the last postulate is Bohr's atomic model is applicable only to the single electron containing species. Okay, like hydrogen is single electron containing species, He plus is single electron, sodium plus 10, that means it has released 10 electron, it is having single electron. So Bohr's atomic model is applicable only to the single electron containing species. And this is also one of the drawback of Bohr also, that it is able to explain only the single electron containing species. So these are the postulates of Bohr atomic model.